Creating realistic facial expressions requires laborious parameter tweaking. Sequential manipulation of 40 or more parameters is slow and tedious for both professional and novice animators. It's very common for users to produce a set of parameter values that leave the space of natural expressions. Given two similar facial expressions still requires users to adjust multiple values to make them look exactly the same. This makes fine-tuning and exploration of similar expressions a non-trivial task. We address these issues by learning a face manifold that allows users to pose faces quickly into plausible configuration, and by introducing a novel interface for interactive refinement of an existing face pose. The space of all possible facial expressions is extremely large, with 40 or more dimensions. However, the subspace of natural expressions is small. We call the subspace a face manifold. In our work, we learn a projection operator to a face manifold which allows us to obtain a natural facial expression even if the original input is not natural. This is done using an autoencoder network that we train on pre-existing data of facial poses that we collected from an animated movie. Our manifold allows for a variety of device inputs to rapidly explore the face space while ensuring that the resulting expression projected onto the manifold remains natural. We show three different interfaces that use the manifold projection. Camera-based interface is the most instinctive interface for face posing. Given an image of a user's face, we utilize face expression analysis software to approximate a subset of muscle activation intensities. Directly using muscle intensity data for posing does not always produce plausible results. By projecting the intensity data onto the face manifold, we're able to find a more natural pose. We augment the traditional slider-based interface by automatically applying manifold projector operator whenever a user moves the slider. This ensures that user never leaves the space of natural facial expressions. The current projected values used to pose the face are shown as a red bar augmenting slider's background to quickly visualize the effect of the projection. We're able to prevent intersections between different parts of the rig as well as self-geometry intersections. Game controllers are familiar interfaces that allow for multidimensional input. We show how users can modify multiple and possibly conflicting parameters simultaneously without leaving the subspace of natural expressions. After posing the face, the user may find that the result is close to their preference, but may require fine-tuning to fit their artistic vision. We propose a novel interface to explore near neighbors of a particular face pose. We visualize the space of similar expressions around the current pose. The darker the green, the further from the manifold. When the user clicks on the current face pose, we show images of neighboring faces to help guide user to the desired pose. The animator can freely navigate within that neighboring space, allowing fine-tuning of facial expression while being aware of how close or far the result is from the manifold. To save the chosen pose, the user clicks on the bookmark button. If the user finds a plausible face but wants to see additional options, they can click the Re-Refine button to generate a new latent space for this face. Even though our manifold was trained on the animation data for a particular character, it does generalize well across different human characters.